Hi everyone, I'm Ben and this is The Snecker Show. And in a previous video, I used some sound effects to make it seem as if my thickness planer turned on while I was doing some maintenance inside it. And this scared the crap out of some people. And I just wanted to take a minute to apologize for not having done that sooner because it was hilarious. Well, it also was a great segue into this video where I'm going to demonstrate a safety feature in this planer that you may not have known about. Now, right inside the front here, there is a little switch right under where my hand is that prevents the planer from turning on when this top cover is removed. And that's great. I've gone in there and done maintenance before and forgotten to unplug it, so it's good to know that there is that secondary feature there to make sure that it's not going to tear your hand off. You also have the switch right here, and you don't want to touch that while you're doing maintenance, right? Finger off the trigger. But you also have that switch that makes it totally, completely 100% safe to work on the inside of this planer, even if it's still plugged in. And I'm going to demonstrate that right now. First, I will turn it on with the cover on. Probably forgot to plug it in again. Nope, it's plugged in. Loose? No. Maybe it was the extension cord. Well, it's always good to keep a voltage detector around. If you don't have a voltage detector, you need one, because all you have to do is touch a wire to see if it's got current going through it. So turn this on. I can check over here to see if I got current coming out of the wall. There is current coming out of the wall. Maybe it's something with the plug. Sometimes plugs go bad. That happens with my jointer every once in a while. All right, there is juice going through the plug, and you got to make sure you're on the black wire side, not the white wire side, because it's actually detecting the voltage. So that's good there. What about going into the planer? There is current going into the planer. So that means that somewhere inside the planer there is a problem that is preventing it from starting. Could be a bad switch, breaker trip in the front. Nope, it's not the breaker again. So I guess the only thing to do is to take off this top cover and see what's going on. And just to show you how great the safety feature is, I'm going to leave the switch on while I take off the top cover, because remember, there's a safety in there that will prevent the planer from turning on if the top cover is removed. The suspense is killing you, isn't it? I have a terrible sense of humor. It's so dry that sometimes I don't get my own jokes. There we go, cover coming off. Who saw that coming? And just in case you would like to see that again, let's take a closer look at that safety feature. You can take off the top cover, and right underneath here is a piece of plastic that presses down inside of that opening. And there's a little piece of metal there. And when that metal is up, it's supposed to tell the planer that it cannot turn on because the lid is off. But that's not working. What's supposed to happen is that when this is depressed, that's when it tells the planer to turn on. But instead, I'm depressed. A little annoyed. You might even say I'm a little cross. When I flipped the switch yesterday and the planer didn't turn on, I went into immediate troubleshooting mode. First, I tried every swear word I could think of, and none of them worked. And the next step was to trace the power from the wall to the machine, and that was fine. And then I took off the top cover, hoping it would be something obvious, like a squirrel jumps out of it or something. And that's when I figured out that it was turning on only when the top cover was removed. No. Well, the truth is that I've been having trouble with that switch for several months now, and it was just the opposite of the problem that I'm having now. Whenever I take the cover off and do some work on the inside, normally before I put it back together, I'll give it a quick function check, just to make sure I don't hear any parts rattling around or see sparks flying out of the top. One time I did that without putting in the wrench first to depress that switch. I just forgot, and I flipped the switch and it turned on. So I knew that something was wrong. But yesterday, when the power didn't turn on at all when I flipped the switch, I had no idea it was the same problem. Now, if you have this planer and you take your top cover off and you can turn it on, that's the way mine was several months ago. So that's an indicator that within the next couple of months, or maybe now, your planer is going to stop working. That's the bad news. The good news is that this is pretty easy to fix. You don't need to take it to the service center, and you might not even need to order a part. So let's do that next. For this repair, you're going to need a 3mm and a 4mm hex wrench or Allen wrench, a number 2 Phillips screwdriver, and the wrench from the top of the planer. Before you get started, make sure that the planer is unplugged, and then you can remove the 4 screws that hold the top cover in place. And then remove the top. Next, we're going to remove this front panel, and to do that you have to take off the speed adjustment lever, the material removal gauge, the screw that's hidden underneath the material removal gauge, these 2 screws in the corner, and 3 little screws on the top. And to make this a little bit easier, you can use the wrench that came with the planer to magnetize the tip of your screwdriver. Use the 4mm Allen wrench for the speed adjustment lever. Use the 3mm for the 2 screws in the bottom corners. Use the Phillips screwdriver for the material removal gauge. And that's why you magnetize. And last, 3 screws in the back. And there is your safety switch. Now, to demonstrate what that's supposed to look like, I pulled out my other planer with the functioning switch. Now let's compare that with the broken one. Just so you understand what you're looking at here, this black wire right here is coming from the wall. When you plug in your planer, this is where the electricity comes first. Through this black wire down here to the switch, the on-off switch. And then when you turn the switch on, it comes through this black wire over here to the breaker, the circuit breaker, where the planer overheats. And from that breaker, it comes up here to the safety switch, and then comes out of the safety switch, and the next stop is the motor. Now, this planer has a little bit of a design flaw, I think, and I think it's an intentional design flaw, and I'll explain that. This is 14 gauge wire, which means that it's rated for 15 amps, because this is a 15 amp planer. The breaker right here, if you can see that, is an 18 amp breaker, because DeWalt knows that if they put a 15 amp breaker here, that it would just trip constantly, because sometimes this planer will draw a lot more than 18 amps. If you're planing wider boards or just using it more continuously or have dull knives, it could be any number of reasons. So this thing is not going to trip until it gets well over 18 amps or 18 amps for an extended period of time. Now what happens is when with this undersized wire that really needs to be able to carry 20 amps or more, when you try to put more juice than the wire is rated for through it, it's going to create resistance, and that resistance is going to generate heat. Now, as this resistance builds up in the wires, it's going to be passed on to the other devices like the switch. And you noticed coming out of this switch right here, it's melted. The terminal is melted, the plastic on the outside. So I guess by the point that gets to this part of the planer, again, being able to get through an 18 amp breaker and not a 15 because it would trip constantly, the heat builds up so much here that it just melts ruin the switch and melts the plastic onto it. So the next thing we're going to have to do is try to break this thing off of that terminal. Now before you remove any of these wires, take out your cell phone and snap a picture of how yours looks. You could just look at mine on the video, but mine are labeled coming from the motor to the plug 1, 2, 3, 5, 4. So yours might be in the right order of 1, 2, 3, 4, 5, or something might have been labeled wrong. Either way, take a picture of it so you know where things go and you don't get confused when you're putting it back. All right, let's hope this works. There we go. All right. And the metal is still fine, it's just the plastic that melted. And the next one, that should just pull right off. Yep, there we go. And then you use your Phillips screwdriver to take out these two screws. And there's your switch. Now to put it back, you just do everything in the reverse order. But I'm not going to put mine back. I'm going to bypass it. Now I know what some of you may be thinking. That's a safety switch. You should put it back where you found it and fix it. Hear me out. This thing is intended to prevent the planer from turning on while your hand is on the inside. All right, that's very important. And it does that, except for when it does the exact opposite of that. No. That's kind of like having a saw-stop table saw that sometimes when it contacts your finger, cuts harder. This is a bad safety feature because it leads you into a false sense of security. Let's look at some other tools in my shop to see if there's a precedence. The door is open. The top is open. The guard is open. I think I've made my point. Now it's just a matter of deciding how to put this thing back together. And really all you have to do is just come up with some way to reestablish an electrical connection between these terminals. One option is, of course, to reinstall the switch. And I ordered a replacement with the intent of demonstrating this, but it's been 2 weeks and the replacement hasn't arrived. And I really don't want it in there anyway, so I'm just going to skip that step. But if you want to do that, it's very easy. You just plug those two terminals back into the switch and screw the switch back into the planer. That's it. Put everything back together and you're done. Other options include just cutting those wires and then twisting them together and putting a wire nut on it. And you just splice them that way, and that will work fine, but I'm not going to do it that way just because even though I have no intention of ever putting the switch back in there again, maybe I might want to sell it one day and I want to put it back in its original configuration. Either way, I always like to reserve the option of undoing a change if I make some kind of a modification to one of my tools. So I'm going to skip that approach. I happen to have some 14 gauge wire available, and that's what I'm going to use to make this patch. Now, you can use 12 gauge as well, but that's a little bit too thick to fit inside of these terminals. So the 14 gauge is what I'm going to use, and this is all 14 gauge wire in here anyway. And for that, all you need to do is cut off 2 little pieces about 3/4 of an inch long and get yourself a 1/16 of an inch drill bit. The only reason you need a drill bit is because this connector, the one that melted, might have a little bit of oxidation or corrosion on the inside, and you can use the back end of the drill bit, not the drilling end, but the other end, has a little bit of a sharp edge on there. Just use this as a little scraper to make sure that any oxidation or corrosion is removed. And that way you know you have a good metal-on-metal connection. And that one is fine. Then you grab your little pieces of copper wire, put one in there, the other one in there, and connect it to the other piece. And then grab a pair of pliers, if it's loose at all, and crimp the terminal onto the wire. That one's a little crispy. And then you can use a piece of electrical tape just to make that a little bit cleaner. And you're done. Time to put everything back together. How many thickness planer videos can one guy make? I wonder how many volts are in my beard. Are you still watching? All right, well, let's take the switch apart then. We are now recording in 8K resolution, so we can hopefully see what the heck is going on inside of this thing. I've already had this open, so I'll just pop off the top cover again and take a look. Oh, first, it's working again, magically, after I took it apart. Now, right off the bat, you might notice some melted plastic on this part. That was down around the bottom where the end of that terminal connector was also melted. And that's just a steel lever that depresses that plunger. And when the plunger goes down, there's a copper or copper colored spring right there that causes these two contacts to snap together. Now here's the mystery. This is the lid down and the planer would not turn on. This is the lid removed and the planer would turn on. Well, when those contacts are together, that means that electricity should be able to flow through the circuit and onward to the motor. If that's up, that means that electricity should not be able to flow past that point and onto the motor. So, what was going on there? I have a theory, and it might be right, and hopefully somebody can validate in the description or down in the comments if somebody's had a similar experience. What I think may have been happening, first I'll pull out this piece to take a look at it. You might notice that this is a little bit shinier on that side than on the inside. This is kind of dull, and you can see that this has been zapped a few times. I think that multiple things were going on with this, and one is that from the tremendous amount of heat that was going through here, enough to melt the plastic on the switch housing and on the terminal coming out here, that amount of heat probably annealed this copper spring, made it less springy, and that made it a little bit easier for this to stay in the down position or in the closed position. And also from me removing the top of the planer while the on-off switch was turned on and the electricity was plugged in, there might have been some arcing between these contacts right here. And that arcing may have caused these two to weld together. It's just two pieces of brass, so the brass may have welded together. Now, again, with the shinier part on the right side and the more dull on the left side, what might have happened is that this thing got welded together like that, and that's why you hear a click when I would push down the first time, but not a click when I would push down after that. So I get stuck there, either because these were welded together or maybe there was some plastic that was putting a little pressure on here, and then I had to tap the thing to get it to go back up. Now, with that shinier part on the outside, I'm going to say that area is more conductive of electricity, and there may have been more resistance in the middle here. So when I took this thing apart, some of that plastic I heard moving around in there, or maybe pieces of metal, may have been parts that were in between the switch. Could have even been little pieces of plastic on there that melted, broke loose, and got stuck between there. Either way, what I think was happening is that when the switch was down, the planer would not run because there was something that was sticking these two together. And when the switch was up, then this would rotate to that shiny piece of the contact, and that would allow the electricity to flow. That's the only thing I can come up with, the only plausible explanation of why it would work that way. Otherwise, if this thing is up, electricity is not going to flow through there, and if it's down, it will. So if this is stuck and there's something in between those two contacts, then it would move over to the place where electricity flowed with greater ease, and maybe over here there was just enough resistance that it wasn't able to arc or pass the current to start the motor. And now that it's working again, if you want to fix your switch, if you have one of these and you do want to repair it, even though I would not use this thing again, even if it was brand new, you can take this thing out and use a nail file or some fine sandpaper or a wire brush, clean that contact off, and then put it back in. And then you can carefully take the rest of this out. Oh boy. Oh boy. Oh boy. Carefully take the rest of that out, and you can clean that burned contact right there. Sandpaper wire brush, and then put it all back together. Put the plunger back in. And put that lever back on the top. And the lid back on, and then when you put in some screws, that'll hold that in place anyway. And then you should have a functioning switch again. That spring might still be a little bit worn out, but you might be able to bend that to make it a little bit more springy. So there we go. Now you know how to do something completely unnecessary for the use of your planer. I bet Chuck Norris's beard is like 240 volts. But a roundhouse kick to the face, free of charge.